Alright, so today we're going to be talking about the systems of equations final. So when we're looking at number 1, we want to graph both of these equations. Now the good thing is they're both in y equals mx plus b form. So this first one here, this -2, that's where it crosses the y-axis. So I'm going to put a dot, an ordered pair, right at -2. The slope here is -4, which means I'm going to go down 1, 2, 3, 4 into the right 1. Down 1, 2, 3, 4 into the right 1. I can then connect those dots with a line. And it looks just like that. This second one, same thing. The only difference is now it's a +4, so I'm going to have an ordered pair right here, right at the intersection. I have a -x, which means that this is really -1, so I can put an ordered pair here, and here, and here, because it goes down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. And if I connect those dots with a line, I can see that my intersection is right here. And this intersection is at -2, 6. Number 2, a couple different ways that I can do this one. First of all, this is already in y equals mx plus b form, so I can use this information to help me graph it. So this -4 means that I start off at -4 in the y-axis. And then a -2 slope means I go down 2 into the right 1, down 2 into the right 1. And I can connect those dots with a line. Now, the second equation makes it a little bit more difficult. So there's a couple of ways that I can do this. One, I can find x and y intercepts and graph them that way. Or two, I can try to get this equation to look like slope-intercept form. If you remember back, we're finding intercepts. If I'm looking for the x-intercept, I'm going to make the y variable equal to 0. So essentially, I get rid of it. So if I get rid of it, I have 2x equals -4. If I divide both sides by 2, my x-intercept is at -2, and that's right here. To find my y-intercept, I would make x 0. So if I make x 0, 2 times 0 is 0. So I'm left with just y equals -4. And I can graph that by connecting the lines. And it just so happens that those two lines are exactly the same. This would be all solutions. Now, if I were to change this second graph into a y equals mx plus b form, remember, when I have terms that I want to move to the other side, I have to do the opposite of it. So this is a plus 2x plus y equals -4. So to move this 2x term to the other side, I have to subtract 2x. So I now have y equals -2x minus 4. Which, if you look back up to the top, is exactly what my first equation was. They are the same, so it's all solutions. Number 3, if I graph those two equations, they are both in y equals mx plus b form. So this tells me I start off at -4. The slope tells me I go down 3 into the right 1, so 1, 2, 3 to the right 1, 1, 2, 3 into the right 1. And I can connect those with my ruler. The next equation, it says 4x plus 3, so I'm going to start at +3 on the y-axis. I'm going to go up 1, 2, 3, 4 to the right 1. 1, 2, 3, can't quite go up that far, but it's about here that it would be. and I can connect those with a line. Now I'm only going to be using these first two dots because this third dot is an approximation. But I'm going to connect those with a line and see that my intersection is right here. And that's at negative 1, negative 1. All right, next page. We're going to be talking about doing it algebraically now. So number 4. This one is a perfect one to do substitution because I have two of them that are y equals. So I'm going to take 4x and I'm going to substitute it right up here. So now I have 4x equals 2x minus 6. I then want to get all of my variable terms on one side, so I'm going to subtract 2x from both sides. So I get 2x equals negative 6. To solve for x, I divide both sides by 2. And I get x equals negative 3. I'm then going to take this and substitute it right here. So it was y equals 4x. But I'm substituting negative 3 in for x. So now it's y equals 4 times negative 3. 4 times negative 3 is negative 12. So the solution is negative 3, negative 12. Number 5. This one is a perfect one for elimination. I don't have any y equals something or x equals something, but I do have two terms that are equal to each other. They are the same. So I'm going to subtract because I want to eliminate the x terms. And if I have a 2x here and a 2x here, the only way I can eliminate them is to subtract them from each other. So 2x minus 2x, that leaves me with 0. 7y minus 3y is 4y. And 13 minus 5 is 8. This 0 can just go away, so I'm left with 4y equals 8. Divide both sides by 4, I get y equals 2. I can then take this and substitute it right here. So I have 2x plus 3. Y is now 2, so I'm going to substitute that in there. And then that equals 5. So I have 2x plus 3 times 2 is 6, and that equals 5. Start solving my two-step equation. I subtract 6 from both sides, so I get 2x equals negative 1. Divide both sides by 2, I get x equals negative 1/2, or I can say negative 0.5. So this would be negative 1/2 and 2, or I could say negative 0.5, 2. Both of those are great. Number 6, perfect one for substitution. I have a y equals something. So I'm going to take this whole thing right here and put it in for y. So I have 2x plus 3y, but now y is negative 2x minus 8. And that equals 8. Undo the distributive property, so I get 2x plus 3 times 2x is negative 6x. And 3 times negative 8 is going to be a minus 24. That equals 8. Combine like terms. 2x minus 6x is a negative 4x. Minus 24 equals 8. Add 24 to both sides to start solving my two-step equation. And I have negative 4x equals 32. 8 plus 24 is 32. Divide both sides by negative 4, and I get x equals negative 8. I'm then going to take this and substitute it right here. So I have y equals negative 2x minus 8. But I know that x is negative 8, so I'm going to do negative 2 times negative 8 minus 8. Negative 2 times negative 8 is positive 16. And 16 minus 8 is 8. So my solution here, x is negative 8. Y equals positive 8. Next question, number 7, another good one for substitution because I have y equals this. So I'm going to take this right here and substitute it in for y. So I have 8x minus 2 times 4x minus 4. equals 12. Undo the distributive property. I have 8x minus 2 times 4x is 8x. 2 times a negative 4 is negative 8, but I'm subtracting it, so I'm going to add 8 to both sides, or add 8 here. So I have 8x minus 8x plus 8 equals 12. Combine like terms. Those are right here, 8x and 8x. I'm subtracting them, so I'm left with 0x plus 8 equals 12. If I get rid of the 0x, I just have 8 equals 12. That doesn't work. So this is no solution, because 8 does not equal 12. Number 8, good one for elimination. I don't have an x equals or a y equals, but I do have terms that are opposites of each other. So I'm going to add those two equations together, because if I add opposites, I get 0. So negative x plus x leaves me 0x. 2y plus a negative 3y is going to give me a negative 1y. And 5 plus negative 9 is negative 4. There's really a 1 right here. So if I divide both sides by negative 1, I get y equals 4. I'm going to take this and put it right here. The reason why I want to put it in this one is because I want to know what x is, and this is negative x, so it'd be one extra step. So I now have x minus 3y, but y is 4. And that equals negative 9. If I start undoing or simplifying this, so 3 times 4 is 12, so I have x minus 12 equals negative 9. Add 12 to both sides. Negative 9 plus 12 is 3. So my solution is 3, 4. And then the last question on this page, number 9. This is a wonderful one for substitution because I have both of them as y equals. So I'm going to take this here and put it there. So I have 3x plus 7 equals negative 4x plus 21. All my x terms on one side, so I'm going to add 4x to both sides. Over here, I create a 0 pair, so that's gone. I'm left with just 21 on the right side. 3x plus 4x is 7x plus 7 equals 21. If I subtract 7 from both sides, I now have 7x equals 14. Divide both sides by 7, I get x equals 2. So the first part of my solution is 2. It doesn't matter which one I'm going to substitute it into, but I'm going to substitute it into the top so I don't have to deal with any negative numbers. But I have y equals 3x plus 7. X is 2. So y equals 3 times 2 plus 7. 3 times 2 is 6, and 6 plus 7 is 13. So I have y equals 13. So the last part of my solution is 13. Next question, number 10, very top of the next page. It says, Logan asked his 20 coworkers whether they own a car or a truck. There were 6 more car owners than truck owners. How many coworkers own a car and how many own a truck? Define variables, write a system of equations, and then solve, interpret your solution by giving a complete sentence answer. So I'm going to let C equal my car owners and T equal my truck owners. It says he has 6 more car owners than truck owners and 20 total coworkers. So I'm going to say, first of all, C plus T equals 20. If I add the car owners and the truck owners together, I should get his total number of coworkers, which is 20. Next, it says there are 6 more car owners than truck owners, which means that the number of car owners is 6 more than my truck owners. This is a really, really good one for substitution because I have a C equals. So I can substitute this, T plus 6, in for C. So I have a T plus 6 plus T equals 20. Combine like terms, I have 2t plus 6 equals 20. Subtract 6 from both sides to start solving my two-step equation. So I have 2t equals 14. Divide both sides by 2, I get t equals 7. I can then substitute that right here. So I have c equals t plus 6. T is 7, however, so I now have c equals 7 plus 6, and 7 plus 6 is 13. This means that there are 13 car owners and 7 truck owners. Next question, number 11, it says Herman and Jackie are saving money to pay for college. Herman currently has $15,000 and is working hard to save $1,000 per month. Jackie has $12,000 but is saving $1,300 per month. And how many months will they have the same amount of money in their savings? Define variables, write a system of equations, and then solve. Interpret your solution by giving a complete sentence answer. So this one looks like it's going to be y equals the total savings, or total amount, and x equal the number of months. Not very imaginative for the variables, but that's okay. So the first equation, I'm going to say that Herman represents my first equation. So he currently has $15,000 and is trying to save $1,000 per month. So the total he has in his savings is $1,000 per month plus the $15,000 he already has. Jackie is my second equation, so her total amount saved is going to be $1,300 saved per month plus the $12,000 she already has. This is another great one for substitution because I have y equals in both cases. So I'm going to take this bottom expression, substitute it in for y in my first one. So I have 1,300x plus 12,000 equal to 1,000x plus 15,000. Big numbers, but don't get afraid. I want to subtract 1,000 from both sides because I want to get all my x terms on one side. 1,300x minus 1,000x is going to be 300x. I have still this 12,000 and this 15,000 left. If I subtract 12,000 from both sides to get my number terms on the other side, I'm left with 300x equals 3,000. If I divide both sides by 300, I get x equals 10, which means that's going to be after 10 months. I want to figure out how much she'll actually have, though, and Herman will actually have. So I'm going to substitute 10 up here. So I have y equals 1,000x, but that's 10, plus 15,000. 1,000 times 10 is 10,000, and 10,000 plus 15,000 is 25,000. So now it says to interpret. So they will both have $25,000 after 10 months. 25. 25. All right, number 12. It says Carly solved the following problem, but she made some errors. So Isaiah bought a total of 32 pieces of candy. He bought 3 times as many soft candies as he did hard candies. How many pieces of soft candy did he have? Define variables, write a system of equations, then solve. So first of all, Carly wrote down that H is equal to the number of hard pieces of candy and S equals soft pieces of candy. So far that sounds good. Her first equation was H equals 3S, which means the number of hard candies is equal to 3 times the soft candies. But it said in the problem that he bought 3 times as many soft candies as hard candies. So here's a mistake. It should have been S equals 3H. Let's keep going to make sure that we're still doing okay. Total pieces of candy is 32. This looks good. So what Carly did then was substituted 3S in for H, like she should have, if she did this problem right. So 3S plus S is equal to 4S. 4S equals 32. Divide both sides by 4. So 32 divided by 4 is S equals 8, and bought 8 pieces of soft candy. So her only mistake in what she did was she did the wrong equation for number 1. So it should have been S equals 3H. So if she would have gone through all of this work correctly, she would have gotten that Isaiah actually bought 24 pieces of soft candy instead of 8 pieces. Spiral review. It says, what is the constant rate of change? Constant rate of change tells me I add 25 as I increase by 5. This continues all the way down the table. Plus 25 and plus 25, plus 5 and plus 5. So I do this 25 divided by 5, which means it's 5 minutes per person. Number 14, it says, which graph matches the function y equals 4x minus 2? This minus 2 tells me I start at negative 2 on the y-axis. That is only letter A. So it can only be A. C crosses at negative 4, and B and D both cross at positive 4. So I was looking for a negative 2 crossing. Number 15, determine if something is linear or nonlinear. That means that I'm looking for constant rate of change. So from 5 to 9 is a plus 4. 1 to 3 is a plus 2. From 9 to 13 is a plus 4. And from 3 to 5 is a plus 2. From 13 to 21 is a plus 8. And from 5 to 9 is a plus 4. So 4 divided by 2 is 2. 4 divided by 2 is 2. 8 divided by 4 is also 2. So this is linear. Do not get confused by because these changes are different. The ratio is still the same. 4 to 2 is the same as 4 to 2, which is the same as 8 to 4. They all reduce down to 2 over 1. And number 16, the range. I'm only looking at the y value, so that'd be negative 3, positive 3, 4, and 5. In fact, those are already written in order from least to greatest. So letter C. If you have questions, please let me know. Otherwise, this is the end of this video for the final of system.